Welcome to getting started with HIL in your data center. Once the nodes and switches are registered with HIL, users can allocate nodes, set up private networks quickly by making a couple of API calls to HIL. Users will have complete freedom to use provisioning system of their choice to manage its share of bare metal servers. To get started, HIL will require to have OBM access to nodes it will control and credentials to switches that will allow it to set and isolate networks. Project is the core object in HIL used for logical resource allocation and isolation. A project can have multiple nodes, networks, or users, but nodes can be part of only a single project at a time. Networks can be shared across projects, and users can have access to multiple projects. Let's explore the HIL API now. We'll be following some hands-on examples and seeing how HIL can be used to register nodes, switches, and to allocate nodes, to provision a node, and to set up networks. So let's do some hands-on examples. For the purpose of this video, we'll assume that we have three nodes named Mercury, Pluto, Jupiter, and switches dummy switch 1, dummy switch 2. So let's get started. Let's first start the HIL server. To interact with HIL, to register any sort of resources with HIL, we need to have an admin user. So let's create an admin user. It's kind of a chicken and egg problem. So we cannot register anything until we have an admin user, and we cannot have an admin user because the database does not have any other user. It will not let you register anything. So this is a special command to get started to bootstrap HIL and make one first user. Now this will let us make other users and other resources in HIL. As you can see, the server is showing us in real time all the commands that I'm executing here from the client. I've also enabled the server in debug mode so that we can see how the connection is processing the requests. So what I've done is I've made a user Jack, which is a regular user, and I've made a user R2D2, which is an admin user. Let's create some nodes. Let's check what is the current state. Right now, as it shows, it's an empty list. We do not have any nodes. Let's go ahead and create some nodes. So creating node is a two-step process in which in the first step we register a node providing its OBM information. In this case, we are assuming that the nodes have IPMI as its OBM, and we register its NIC. We need at least one NIC so as to connect to the network, and once they're registered we can query them using this command. So this shows totally how many nodes are registered with HIL, and if we want to check how many of them are available for us to allocate, we run this command. So right now all the nodes are free and available. To do anything useful, we'll need network, and hence we'll have to also register switches. As with the previous command, list switches will tell you how many switches are registered and thus controlled by HIL. Right now none. So let's register a few switches. So switch registration depends on the make and the model of the switch, and all the arguments are not always same, they differ. So here I'm assuming a mock switch, so we have a mock driver for our testing purpose, and it takes three arguments, that is the IP address, the username, and password. Depending on the switch, it may have variable amount of arguments. This is for demonstration purpose only. So let's look at what switches do we have. So we have now two switches registered with us, and let's check the details. So show switch name will give us details about the attributes of the switch. So right now dummy switch 1 has no ports that are controlled by HIL. Similarly, we can do for the node also. Show node Pluto. As we can see, Pluto has one NIC 880 with this MAC address. It is not connected to any networks. Neither is it associated with any project. Let's do it again. Okay, it's not associated with any project. What is a project? Why it's needed? I'll come back to that soon. Let's register some ports with the switch. And now if I do show switch dummy switch 01, it will correctly tell me that port number 01 and 09 is under the control of HIL and HIL can allocate it. Now all logical resource allocation and isolation is done by the object project. So we create a project and we allocate node in it, we allocate users in it, we allocate networks in it, and it is the hub of logical resource isolation. So let's create a few projects. Oh, I got the command wrong, sorry. Project create 1 and 2. So now if I do list projects, and yeah, so no nodes are allocated in this project, hence it's showing an empty list. Let's create a network and allocate it to this project. And now if I run list project networks, it shows me that project 1 consists of one network, net01. Another way of looking at it is looking at all the networks that are created under HIL. That shows that network 1 has been created and it is owned by project number 1. Now we will see how we can allocate a node to a project, attach a network and provision it. First, let's check if we have any nodes available in the free pool. We have one node. We will allocate this node to project BMI Infra. Let's see how many nodes it already has. It has 5 nodes as seen in the output. We will allocate this node sysco 23 into this project BMI Infra and we will confirm that it is allocated. Whenever we are in doubt what argument a command needs, simply pressing enter will provide the usage. In this case, BMI Infra is the project name and sysco 23 is the node name. Running the list command again will confirm that sysco 23 is indeed allocated to project BMI Infra successfully. And there are no free nodes available anymore, as we will see now. The node also shows that it is allocated to project BMI Infra. Now let's connect this to a network. We can confirm this by doing show node on the node sysco 23. As we can see, it's connected. Next, we will show how to provision a node. For that, you can use any provisioning system of your choice. We will be using BMI, our in-house rapid provisioning solution. As can be seen from the console output, Cisco 23 is in power off condition. Following command will start provisioning process and provision CentOS 6.7 on the node using our provisioning BMI provisioning system. This sets up the node for provisioning when it boots up. So let's power cycle the node using the API of HIL. Now it's a long wait, but not so long. BMI boots faster than the traditional DHCP server, Pixie server. Let's make it a full screen. Post is usually longer when provisioning bare metal servers. This shows that the node has correctly identified the operating system that our provisioning system wanted to deploy. Let us log in and verify the IP address to make sure that it is indeed the same IP address of the network that we had set from HIL. Now let's do an SSH to the system and also verify that the MAC address of the system is same as the one provided with HIL. As you can see, we have successfully provisioned a bare metal node from HIL using a provisioning system of our choice. Thank you.